chaos and order. We think of them as opposites, two forces locked in an eternal battle. But here's the thing. Chaos and order aren't opposites at all. Chaos contains order within it, and order, it hides chaos inside. They are one and the same. How do we know this? From the air. Yes, from the weather. In 1961, a meteorologist named Edward Lorenz was about to stumble onto something extraordinary. And it all started with a very human impulse, a little bit of laziness. On an ordinary day of trying to forecast the weather, Lorenz decided to harness the power of computers, machines that were just beginning to transform every field of science. He created a mathematical model, fed it a set of numbers representing current weather conditions, and it could predict the weather with accuracy down to just a few minutes. Naturally, Lorenz wanted to push it further. His dream was to continuously update the current conditions and extend the predictions over longer and longer periods. And at first, it worked beautifully. Minute-by-minute predictions stretched into days, then weeks, and they were remarkably accurate. Then one day, Lorenz decided to rerun a prediction. But instead of starting from scratch, he stopped the computer halfway through and used those midpoint results as his new starting point. Thinking he'd saved himself some time, Lorenz went for a copy break. When he came back, everything had gone haywire. The computer had started normally enough, but as time progressed, the predictions went completely off the rails. There was a massive divergence in every single calculation. So what happened? Looking back at his work, Lorenz discovered something remarkable. While the computer printed results to 3 decimal places, it was actually calculating internally with 6. Lorenz had entered 0.506, but the actual number was 0.506127, a difference of just 0.000127. Tiny, almost nothing. And yet the results were dramatically different. Here's what was really going on. Even though the starting conditions appeared identical, that minuscule difference in the numbers was compounding over time, growing into enormous, unpredictable deviations. We look at a butterfly flapping its wings and think, what difference could that possibly make? But that butterfly could trigger a hurricane on the other side of the world. And without realizing it at first, Lorenz had just discovered that those butterfly wings matter far more than anyone had imagined. What Lorenz had found were the seeds of chaos. The seeds of chaos theory. Chaos theory is one of the most beautiful theories in all of science. At its core, it's the science of predicting the behavior of systems that appear on the surface to be completely unpredictable. Think of it as a mathematical toolkit that lets us extract breathtaking patterns of order from a sea of chaos. A doorway into the complex structures of everything, from the beating of your heart to the orbits of asteroids. One of the most striking fields in all of modern mathematics. At the very heart of this theory lies the idea we started with. Chaos and order are not opposites. Chaotic systems may look random and unpredictable from the outside, but inside them ticks a perfectly deterministic mechanism, working like clockwork. And it works the other way too. A system that appears perfectly orderly can actually emerge from chaotic origins, and something that looks stable on a small scale can trigger complete chaos in the long run. So, what are we really talking about here? Everything, actually. But let's paint a picture together with a few powerful examples and some surprising connections. The story of Lorenz we started with told us something profound. Tiny changes in calculations can compound again and again, ultimately producing results that nobody could have expected. This is the discovery that gave birth to one of science's most famous metaphors, the butterfly effect. What Lorenz was really trying to say was this: as a meteorologist, predicting the path of a hurricane was everything. Lives depended on getting it right. But no matter how carefully you plot the predicted path, even a breeze from a butterfly's wings at the very start could be the difference between a hurricane hitting Texas or striking Mexico instead. And perhaps the best everyday example of this, billiards. Think about the opening break shot. No matter how steady you make that first strike, no matter how hard you try to hit the exact same spot every time, the tiniest variation in your grip, your speed, your angle, and the balls scatter in completely different directions every single time. And this phenomenon sits right at the foundation of chaos theory. But here's the crucial point. Those balls never break the laws of physics, not once. The system is entirely deterministic. It only appears random to us because the tiny factors we can't perceive are the ones making all the difference. All these tiny factors combine to create what scientists call a prediction horizon, a wall beyond which prediction becomes impossible, no matter what you do. For weather, the prediction horizon today sits at about 1 week. That's how far our best forecasts can reliably see, and it took better equipment and decades of progress to get even there. 50 years ago, that horizon was just 18 hours. Beyond that, impossible. So where's the ultimate limit? According to the math, 2 weeks. That's the absolute maximum for accurate weather prediction. Even with the most powerful supercomputers, the most advanced sensors, even if you launched into space, this is the limit, period. In fact, the solar system we live in is itself a chaotic system. Its prediction horizon, about 100 million years. And remarkably, it was the first chaotic system ever discovered, even before chaos theory itself existed. Behind this discovery stands a brilliant French mathematician, Henri Poincaré. In 1887, Poincaré pointed out something extraordinary. Newton's law of gravity could beautifully describe how two celestial bodies move in each other's orbits with stunning precision. But the moment you add a third body to that system, everything falls apart. Every equation breaks down. If you want to calculate their three-body system, you have to calculate their movements step by step, moment by moment, constantly feeding the latest results back into the equations and starting over. Without that constant recalculation, you simply cannot know where those bodies will be even a few million years from now. And we can't forget the chaos effect either. When an asteroid enters the equation, any celestial body really, you need to be extremely careful, especially when our future is at stake. This is exactly why organizations like NASA track every single asteroid they can find, constantly, relentlessly. You might calculate today that an asteroid won't hit us. But if at any point it passes through a gravitational field, every calculation needs to be redone from scratch. And honestly, all these possibilities and uncertainties stress us out because deep down, we love stability in every sense of the word. Even if we know it's not a 100% possible, we still want everything to be predictable in our personal lives and in the world at large. But here's what chaos theory tells us about that. Yes, nature can be unpredictable. No matter what you do, Everything can spiral into randomness and chaos. But what you need to do is turn that to your advantage. Yes, use chaos itself to your benefit.
But how?
As we've been saying from the start, inside every chaotic system, there are hidden variables, constants, and patterns of order. You just have to find them. Here's an example. Take a ping pong ball, go to the middle of the ocean, drop it from above. Where does it go? The surface. Now dive deep underwater and release it. Where does it go? Right back to the surface. No matter where you start, you know exactly where it's heading. Mathematicians call this an attractor, a set of values that a chaotic system naturally tends toward no matter where it starts. A point of gravity for chaos itself. Look at the ocean and you see pure chaos. But once you know the attractor, the point everything is drawn toward, you can extract order that actually works for you. Let's look at it from a completely different angle. Your heart. Millions of cells inside it, contracting and relaxing in perfect synchrony, pumping blood through your body in a delicate balance. Each of these cells is part of an incredibly complex, chaotic system. They are the attractors, the points of convergence. And behind it all, electrical signals, a system of countless elements that is, at its core, chaotic. And when they fall out of sync, trouble. Doctors call it fibrillation, an irregular heartbeat, what we know simply as palpitations. That's why doctors rush to do an ECG, an electrocardiogram. They're looking directly at those electrical signals. And in fibrillation, they can see it clearly. The signals are corrupted, the synchronization has broken down. Then comes the defibrillator. We've all seen it in movies. The electric shock, the dramatic moment. We think they're restarting the heart. But no, what's actually happening is a reset of synchronization, restoring order, rebuilding the delicate balance within the chaos. We could give you many more examples. The stock market, the entire financial system, every competitive sport, life itself. Now, we could dive into the technical depths, fractal mathematics, phase spaces, and all the heavy math that supports this theory. But I think there's a more meaningful way to wrap this up. As I've been saying from the very beginning, physics and mathematics are really telling us the story of life itself. And chaos theory? It might tell that story better than any other theory we have. Here's what it's telling us, in essence. We live in chaos. Nature, the universe, everything around us, it's chaos. No matter how predictable we think the system is, what we actually have is a system born entirely from randomness and unpredictability. And within this system, temporary islands of order. This is why quantum mechanics shook us to the core. When you look at the atoms that make us up, you find a sea of unpredictability and probability that defies every human instinct. And yet, when they all come together, they create you. They create me. They create all of nature and the entire universe. And this theory tells us something else, that tiny moves create enormous consequences, that everything is a butterfly effect. A single step you take today to change your life, 10 minutes you dedicate every single day. This theory explains the hurricane that can create 10 years from now. That even a small act of kindness, a smile to a stranger on the street, can start a chain reaction you'll never even see. That when you give a book to a child, you might not just change that child's destiny. You might change the destiny of all of humanity. What chaos theory is really telling us at its heart is why science matters,
why we need to talk about science before anything else.
And as always, until we meet again, I'm glad you exist. With love.